Hi, I'm Alyssa Henry, and I lead our storage services business for AWS. As John mentioned, probably the most well-known of our services is Amazon S3. There's several others as well. Amazon S3 has been out. We launched it about 5 years ago, early 2006, and it's been growing like a weed exponentially every year to the point where we now have over 566 billion objects stored in S3. There's a number of reasons or a number of things that have been sort of fueling the growth of S3. And one of those is that customers continue to expand the number of ways that they find to use the service. So, for example, we've got customers like Netflix who use S3 for digital asset storage. So they store all their movies in S3. Likewise, we've got Dropbox, who uses S3 as the cloud backend behind their file syncing and sharing service. And then we've also seen new use cases develop, like that are more related to big data since we launched our Elastic MapReduce offering, which is our Hadoop service, back in 2009. We're seeing more and more customers use S3 together with EMR to solve their big data challenges. So today, I'm going to talk a little bit, give you a very quick, very fast overview, because I've only got 5 minutes here, on how customers are using AWS to solve their big data challenges. So I thought I'd start first with telling you a little bit about how Amazon internally uses AWS to solve some of its big data challenges. So Amazon has lots of data. For example, we have 1.5 billion items in our retail catalog. We have over 200 different fulfillment centers worldwide now that ship out the products. So engineers at Amazon are often tasked with finding scalable and affordable solutions to some very interesting data-oriented problems. There's a whole ton of them. One of them, for example, is a problem that seems pretty straightforward on the surface, which is which items should we put in our high-value secured cages within a fulfillment center to help prevent theft? It doesn't seem that hard until you think about all the data that you want to bring together to make a good decision on that. So for example, you need to know, well, how big is the cage? How big are the items to figure out how many I can put in there? What is high value? High value might not actually be the same as high price. So for example, if there's some hot new consumer electronics things with limited availability, the value of that might be much higher than what the actual price listed on the site is. And then criminals, it turns out, adapt really quickly. So you want an algorithm, or you want a way to deal with this that can move and respond as quickly as they do. So one of the things that we've learned at Amazon is that traditional big data warehouses are A, really expensive, B, they actually don't scale very well, and C, they're actually pretty slow. They're actually too slow to be used as a platform for a lot of the machine learning type of problems that we want to solve. So going back to that example of which items to put in a high-value cage, let me tell you about one of the ways that one of the teams within Amazon has decided and has started leveraging the AWS cloud to solve their problem. So that team that's figuring out what's going in the cage, what they've done now is we now have all of the product catalog data for all the 1.5 billion objects in our catalog stored in Amazon S3. We get about 50 million updates a week to that catalog that get in and then stored in S3. This team now that's trying to figure out how to classify those items and figure out what to do with them has built a process that leverages that catalog data in Amazon S3. They spin up an EMR cluster about every 30 minutes to process and classify the results, and then they spin it down. And then the rest of the website picks up the results of the reclassified information in S3. What's interesting about this case is this is one where traditionally or previously we've been using a big data warehouse. There had been a human process where they'd run reports and get the data out of the data warehouse. They'd apply judgment, and then someone would code up the SQL to update the stuff in the database. That process was really slow. It didn't scale very well. It used to take days to even weeks to get things updated. With this new solution now, stuff gets reclassified in under an hour, and it costs a lot less. So we've had lots of big data problems at Amazon, but we're not unique. Big data problems exist everywhere. We have lots of customers today using AWS to solve the big data problems that they have in their business. These are some examples. Let me drill into one specific example, which is Yelp. So Yelp is a local review site. They have about 50 million visitors a month, 18 million customer reviews so far. And they use AWS in a lot of different ways to improve the experience and relevancy of their site. So we can look at a specific example, which is how they're using AWS to go figure out better spelling suggestions or do auto-correction for spelling on their site. So what they do is they've actually built an algorithm that takes a look at all of the terms that customers enter into the search box and then pairs that with click-through logs and figures out what did people search on and then what did they ultimately actually select, and then figures out the patterns to understand what might be a misspelling. So what they do is they throw all of their data into S3. So that's things like user search data and final click-through information. They then spin up an EMR cluster of about 100 virtual servers to go process that data. That data is split up or chunked and sent out to each of the different servers via the EMR software for parallel processing. And then the results are stored back in S3. Their site then can come pull the data out of S3 and update the experience for their customers. The great thing about this is that when they're done processing that, they can shut the cluster down and they no longer need to pay for it. They only pay for the cluster for the time that they use it. And what's even cooler is that all of the 80 engineers that work at Yelp can do this whenever they want, whenever they have a big data problem. And it turns out they do this a lot. On the average week, they spin up about 250 different clusters to go process various jobs for their site. So last example here is a partner of ours called Cycle Computing. They had a similar sort of thing, but instead of spinning up 250 node cluster, they actually spun up a cluster with 30,000 cores. They shared some data with us in terms of what they thought it would have cost them if they'd done it themselves, even using commodity hardware. They estimate it would have taken $18 million to build a similar kind of cluster. Using AWS, it cost them about $1,300 for an hour, and when they were done, they could spin it down. So what I want to leave you with is think about what could your business do? What problems could you solve if every one of your developers had access to a supercomputer? So thank you, and thank you to the team at Yelp for sharing their case study with us and letting us share it with you. Thanks.
Thank you so much.